Hi everyone, welcome to this video where today we are learning how to use the distance formula and the midpoint formula. So the distance formula is a formula that we use to calculate the distance between 2 points on the coordinate plane. And if I gave you two ordered pairs and I labeled them as x sub 1, y sub 1, x sub 2, y sub 2, we would plug those four values into this formula very carefully and we would do our evaluating. And I'm going to show you exactly how to step-by-step do it the right way so we don't make any mistakes. But notice what the formula is asking us to do. It's saying subtract the x values from each other. So do x sub 2 minus x sub 1 and then square that answer. Then we need to do y sub 2 minus y sub 1. So we're going to subtract the y values from each other and then square that answer. After we do our both subtractions and we square them, we then add them together. And then that final answer that we get after we add them together, we take the square root of it. So let's take a quick look. It says here for the points -4, 4 and 5, -2. We're going to find the distance. So the distance between those points, if I label them as x sub 1, y sub 1, x sub 2, y sub 2, would be to do d equals, the distance equals, the square root of, it's x sub 2 minus x sub 1. So 5 minus -4 squared. So x sub 2 minus x sub 1 plus, then I do y sub 2, -2, minus y sub 1. So let's see. 5 minus a -4 really means 5 plus 4, which is 9. -2 minus 4 really means -6, so this is plus -6. And I have to square both of those values. 9 squared is 81. -6 squared is 36. I go ahead and I add them together and I get 117. Now, I can write this answer as breaking it apart as a simplified radical. So 117, if I wanted to think about the biggest perfect square that goes into 117, it may take me some time to test it out, but it is 9. It's 9 times 13. Square root of 9 is 3, and we just leave radical 13. So the distance on the coordinate plane between those 2 points would be 3 radical 13 units. The next thing that we're going to learn how to do is calculate the midpoint. When you have 2 points on the coordinate plane, the midpoint is literally the point that would be in the middle of them if I was to connect them. So I can calculate the distance from 2 points on a number line, and I can also figure out exactly what that point right there in the middle would be. And the formula is actually to add the x values and divide by 2, which is really to find the average or the mean of those values, and add the y values, divide by 2. So it's the average of the x's and then the average of the y's. So if I gave you those same two ordered pairs and I asked you to calculate the midpoint between them, we would go ahead and we would add our x's together, so -4 plus 5, and then we would add the y values together. Now, after we go ahead and we add them, -4 plus 5 is 1, and 1 over 2 is just simply 1/2. 4 plus -2 is 2. 2 divided by 2 is 1. Now, I want to show you, if I was to actually go ahead and plot those 2 points on the coordinate plane, here's where -4, 4 is. Here's where 5, -2 is. Here's that midpoint that we actually calculated, and it's actually in okay, and that midpoint is right here at 1/2, 1, and I can see it's halfway in between those 2 points. Now, something else I want to show you is that the distance formula actually is Pythagorean theorem, just kind of unfolded. If I was to take the distance between these two points, and make a line, it's really the hypotenuse of a right triangle. And remember, Pythagorean theorem is a squared plus b squared equals c squared. So if I wanted to find this length here, I could really do 9 squared plus 6 squared equals c squared. Look at the distance formula. We actually did that. 9 squared plus -6 squared, we got 36. We would add those two together, and then take the square root. And in the Pythagorean theorem, the same thing happened in the distance formula. It's really the exact same idea. All right, let's take a look at some other problems here. It says, okay, do the coordinate points form a right triangle? Use the distance formula and the Pythagorean theorem to prove your answer. So here I have these points, A, B, and C. And what I'm going to do is I'm going to calculate the distance from A to B, then the distance from B to C, and then the distance from C to A. If you feel like you want to pause right now to just try the distance formula out yourself, you certainly can. Otherwise, stay along with me. So from A to B, so the formula is to do the square root of, we go ahead and we subtract our x's. Now, technically, you can put them in a certain order, but honestly, it's not going to make a difference. You simply subtract the x values from each other. So I'm going from A to B. So -2 minus -4 squared plus, then I look at the y values of A and B. -3 minus 5 squared. Now, -2 minus a -4 really means -2 plus 4, which is 2. -3 minus 5 is really -8. 2 squared is 4. -8 squared is 64. If I add them up, I get 68. Biggest perfect square that goes into 68 is 4. 4 times 17. And that becomes 2 radical 17. Let's go from B to C now. So I subtract my x's. Again, doesn't matter what order you subtract them in. So if I do 2 minus -2, and then -2 minus -3, so I'm subtracting my y values. 2 minus a -2 really becomes 2 plus 2, which is 4 squared, plus -2 minus a -3 becomes -2 plus 3, which is 1. 4 squared is 16, 1 squared is 1, and I get the square root of 17. So this length here from B to C is the square root of 17. The last one that we need to take a look at, C to A. So point C to A. Square root of, subtract our x's, so 2 minus -4 squared, plus, now subtract your y's, -2 minus 5 squared. 2 minus a -4 really becomes 6. -2 minus 5 is -7. 6 squared is 36. -7 squared is 49. Add them up, and I get radical 85. So I have these 3 different lengths, and they look kind of funky to us. If we put them in decimal values, actually put those radicals into the calculator to see the decimal, they'll probably make a little bit more sense to us on the coordinate plane, but those are actually our answers. Now, if I wanted to see whether or not this triangle was a right triangle, I could actually plug the values in the Pythagorean theorem. So I want to check, does 2 radical 17 squared, so this side of AB, I'm going to zoom out just a bit so we can see a little bit more, does this side of 2 radical 17 squared plus the little side of radical 17 squared equal radical 85 squared, what I think the hypotenuse would be. So let's see, 2 radical 17 squared, I square the 2, it's 4. Square root of 17 squared is 17. Square root of 17 squared is 17. Square root of 85 squared is 85. 4 times 17 is 68. 65 plus 17 is 85. So those 3 points, we found the distance of each side using the distance formula, and then we actually plugged in those 3 distances into the Pythagorean theorem to prove that that triangle is actually a right triangle. Now, midpoint formulas. If I go from A to B and I want to find the midpoint, you add the x's, divide by 2. So from A to B, I would add those x's, divide by 2. So -4 plus -2. Then I look at the y values. You add those up. 5 plus a -3, divide by 2. -4 plus -2 is -6. -6 divided by 2 is -3. 5 plus -3 is 2. 2 divided by 2 is 1. So guess what? -3, 1 is the midpoint between those 2 ordered pairs. Let's do the midpoint from B to C. So I go from B to C, I add the x's, That becomes 0 divided by 2 is 0. I add the y's. So negative 3 plus negative 2 is negative 5. Negative 5 divided by 2 is negative 2.5. And if I was to go ahead and plot that point, this is my midpoint, 0, negative 2.5, it's directly in between those 2 points. Last one, midpoint of C to A. So let's go ahead and add those x's. 2 plus a negative 4 is negative 2. Negative 2 divided by 2 is negative 1. And let's add the y's. 5 plus a negative 2 is 3. 3 divided by 2 is 1.5. And if I was to plot that point of negative 1, 1.5, it's directly in between. It's the perfect midpoint. I know this was a quick video. Hopefully it was helpful for you. Rewatch as much as you need. Thank you so much for watching.